The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, good afternoon, good evening, don dias, everybody out there who is listening to us and has joined, and I'm sure many more people. We have 35 people with us already. I'm sure we'll have another 35 or more in the next few minutes. Thank you for joining. This is Krishna Badula from IFES and from IUC, and it's exciting. Okay, we got this this amazing webinar for you today. And as you know, as you can see, the title is the simulation-driven design process of Altair resources and software for engineers and designers. This is from a company known as Altair that many of you might be familiar with. Our two distinguished speakers, as you can see, are Dr. Matthias Gölke, who's the Senior Director, Business Development and Academic Markets. And then we have Jim Ryan, who is the VP for System Solutions. So both of them will be sharing the stage as we go through this presentation. Just to give you a brief background on both of them, Dr. Matthias is responsible for global academic programs, and a key aspect of the academic activities is communication of Altairs university offers, which includes software, academic forum, training and education of students and teachers, student competitions, academic events and workshops, and joint research projects. Prior to his current position, Matthias was a university account manager in Germany, Austria, and Switzerland. His experience in Altair includes project management, technical support, training management, custom software development, and software release, as well as technical documentation. Before joining Altair Germany in 1999, Matthias worked as a postdoc at the University of Karlsruhe, Germany, and the Free University of Amsterdam in the Netherlands. Dr. Matthias holds a PhD degree from the Free University of Amsterdam. Jim Ryan, who's the VP for System Solutions, joined Altair in November 2017 in a strategic role to help develop, promote, and support its math and system simulation tools for model-based development. His passion is helping engineers and their companies develop better products faster through the use of best-in-class engineering simulation software and services. His focus is on making complex software understandable and useful to customers by connecting the dots between their goals and Altair's software capabilities, especially pertaining to model-based development. After receiving his master's degree in mechanical engineering from Stanford University, he spent his entire career in customer-facing roles with leading companies in CA software, including SDRC, MDI, MSC, MathWorks, CD, Siemens, and now Altair. So I'm going to hand this over to, I believe, first to Jim, right?
Yep.
And I'm going to make you the presenter. And you just have to click show my screen, and you'll be ready to go. Fantastic. You're on, Jim.
Great. Thank you, Krishna. And thank you, everyone, for joining us today or in the future through the webcast recorded. Matthias and I are delighted to be with you today to talk about how we at Altair Engineering support teaching and learning at universities worldwide.
So, Matthias, you can also say hi at this point if you want, so that you can.
Okay. Hello, everyone.
Yeah.
As Krishna introduced, I'm involved with global strategy for Altair, so I'm going to start off today's presentation giving a big picture context of Altair if you're not already familiar with us, who we are, what we do, what our mission is. I think that will help lead in and help you understand our academic program, what our objectives and vision are there, and Matthias will provide more details about that. At a glance, Altair seeks to help its customer companies and universities transform design and decision making by applying simulation technology, machine learning, and optimization throughout the product life cycles of the products that they develop. That's it in a nutshell, if you would. That provides the background or context for everything we'll talk about today. We started the company in 1985. Jim Scappa, our founder and CEO, is still with us. The company went public roughly 2 years ago. Roughly $400 million per year, split evenly around the world. We are an international company and proud of that, with offices and customers worldwide. There's a few key takeaways for today that I hope you will remember afterwards. In working with universities, our objectives are not to make a profit from the schools, nor to coerce the use of only our software. And we certainly don't expect faculty to train students on how to use our software. That's our job, and we'll gladly help with that. So what are our objectives? Really, we are intent on helping engineering students prepare for jobs after graduation, or maybe even during school and internships. We want to help course instructors complement the theory that they teach through the use of simulation technology that complements that theory and leads to aha moments for the students as the theory comes alive, if you will, in a more practical sense. And we also hope to help universities streamline their engineering curriculum, reusing technology from one class to another, perhaps, as the students go from first year to second year up through graduate level. Perhaps reusing the same sort of technology across departments, mechanical, electrical, aerospace, biomechanical, etc., and even into student project use, all by leveraging simulation such as ours. Our commercial customers are worldwide as well. Not surprising, our offices are near them to support them as well as we can. They range from very large BMW and Boeing and Tata and Toyota all the way down to startups, so it doesn't really matter how big they are. As long as they are seeking the use of simulation technology to design better products faster, we like to try to help across many different industries, automotive, aerospace, etc. So with that sort of set of customers in focus, you can imagine that they have certain challenges. So there are trends and things happening in their world which affect us at Altair, as well as you folks in academia. So together, Altair and academia, we'd like to handshake and form a three-way connection with our mutual customers in industry. Because these companies, these engineers in industry, realize that everything is smart and connected these days. And products that they make are getting ever more complex, not just because they're smart and connected, but because consumers are demanding more performance, more output from these products. And they want more types of products, more choice. So these different the complexities and demands on the performance of the products lead to the need for massive exploration of new ideas and getting information about the designs of products faster. As the information explodes for how much data that the engineers are getting, that leads naturally to the convergence of simulation and data intelligence. So these are the challenges that we are trying to help companies address in industry, and I think it serves as a context for what we would like to do with students and faculty in engineering universities. How we help is through by offering a broad spectrum of technology and easy access to that technology. Matthias and I are going to get into more details about the technology that we can provide, but suffice it to say, on this slide, we wanted to remember two things. One, our brands, which you may have not heard of before. You might have heard of HyperMesh for finite element analysis, pre and post processing, or OptiStruct as a solver. Those are under the HyperWorks banner. Also available as Solid Thinking as we try to help more concept design and design engineers use our tools. And on the other end, we have SmartWorks and KnowledgeWorks for IoT and data intelligence, respectively. So quite a broad spectrum, and all enabled through one simple, affordable units-based licensing model. So whether you're in universities or in companies in industry, it doesn't matter. We want to be able to access a lot of this technology without having to pay separately for every piece of software. So what are companies doing with this software? What are universities doing with it? Essentially, they are designing products at the product level, the system level. In years past, companies designed at the component level or the subsystem level, but they realized that optimization at that level doesn't necessarily lead to optimization at the product level. So we are enabling system simulation that's multidisciplinary. And we're doing that by offering 3D simulation based on 3D CAD, as you can see here, 3D models, but also 1D and 0D, which I'll explain more in a moment. But the notion that multidisciplinary is possible through the Altair suite is very important, because these modern complex products have movement, so multi-body dynamics is needed. They are tracking and controlling and intelligence systems, so control systems are needed. There are motors involved, electric motors or other types of pneumatic and hydraulic actuation. There are structural properties that need to be factored in, if you will. As in this case, we have a robot lifting a flexible plate from one station to another station. We have to understand how that operation will proceed. In the lower part of this slide, you can see examples from aerospace, off-highway, and radar antenna. We are helping companies lightweight these systems without risking failure. So optimizing and balancing the trade-offs between trying to use less material, but but still have it be structurally sound. And then combining those different technologies along with computational fluid dynamics and electromagnetics to make sure that we have good transmission of signal despite having to deal with environmental loads such as wind loads. So that is a big picture. How are we really enabling those different types of simulation? As I mentioned, we're combining three-dimensional simulation. In this example of a suspension, we can use 3D geometry for a quarter suspension, or we can look at the full chassis suspension, or we can even put that into a full truck and drive it on a virtual road. But that requires the access to 3D geometry. So before we have 3D geometry, we still want to be doing some calculations based on requirements, fuel efficiency, for instance. We don't need geometry for that. We can do that sort of calculation in what we call 0D or equation-based modeling and simulation. We also have technology that enables block diagrams or 1D simulation. Our 0D tool is called Compose. It's based on open matrix language, OML, whose syntax is compatible with MATLAB and Octave. But this product has been intentionally built to be multi-language, so you can use it to create and run Python scripts as well. We realize that the world, as I said earlier, we're not going to dictate what tools people use. We're simply trying to make our tools open and flexible. But of course, we also try to make sure that Compose works very well with our HyperWorks suite to pre-process models and post-process simulation results. Then Activate, Altair Activate, is our open integration platform that enables this multidisciplinary system simulation. So by itself, it offers built-in modeling from a signal-based approach, or a physical-based approach, physical modeling with Modelica. You can even model mechanical systems, structural systems, thermal systems, along with electrical and electronic systems with SPICE, using these open standards. Also relying on Compose, as we talked about earlier, for the 0D portion, and then connecting tightly through co-simulation to Altair's native 3D simulation tools, as well as to third-party simulation tools, again, through an open standard, the functional mock-up interface. That's how we enable the 0D, 1D, 3D spectrum of simulation. Going back to that diagram now, how does that relate to universities, our subject for today? Well, essentially, we believe that many different courses across many different departments in engineering can be taught using technology like ours to complement the first principles, enable students to do calculations, analyze the results, have those aha moments, work in teams, and complement what the teachers want to teach in perhaps a more interactive fashion. They can show those simulation models that I showed earlier, and then perhaps do some what-if studies. What if we change a parameter in our design? Will that improve performance or make it worse? And then we don't have to limit our focus to just single classes. We can design entire curricula through first year up through graduate studies to involve simulation technology like this, and therefore streamline the curriculum, make it more efficient, be able to teach more faster. Michigan Tech University is a fantastic example of this. Several years ago, they realized what you all know, which is they need to efficiently prepare their engineering students to apply this type of industrial strength simulation technology, but they don't have a lot of extra space in the curriculum. So their solution was to develop a coordinated 4-course sequence, what they call mechanical engineering practice, using this multidisciplinary software, simulation software from Altair. In the end, the value they gained was that students truly understood or comprehended the simulation-driven design approach that companies use to developing better products faster. The students were able to hit the ground running when they took jobs in industry, and through this coordination of sequence, the later teachers, the later courses in the sequence don't have to spend as much time on the simulation software. They can just expect the students to know how to use it. All with the goal, as Professor Chuck Van Carson said, of teaching the students the skills that they'll need on the job. So the last thing I'd like to leave you with before I turn things over to Matthias is, as we in academia locking arms with us in Altair, we hope to meet the needs of engineers in industry by preparing students for the complexity they're going to face when they graduate, but yet teaching more in the same amount of time. Also accommodating the flexibility that is required in schools these days, allowing students in maybe a flipped classroom sort of environment to be explorers and makers and to do more on their own. But in order to do that, they need access to tools like ours, and we try to make it easy and affordable to get that access. Also, we realize that students need to work in teams. They need to work on multidisciplinary projects, hands-on experiential that complements the theory of the classroom. Last but not least, we're all trying to foster these holistic system-level thinkers, what someone in engineering academia talked about years ago as T-shaped engineers, both being able to think broadly and overarching, but also be expert in certain disciplines. So with that in mind, let me turn it over to Matthias, and he's going to tell you how we can help schools address some of these challenges.
Okay, thank you, Jim. That was an excellent introduction to this whole program. And I'd like to remind about 60 people participating. I'd like to remind all of you that you can text your questions and comments as they enter your mind and put them down so that you don't forget them. And with that, I'm going to make Matthias the presenter. And just a second, he will be on. Matthias,
Yes,
show my screen and you'll be all set.
Yes, show my screen, and I need to start my presentation now. Display settings, swap presenter slide.
And then, yeah, perfect. You're all set.
Yeah. Okay, so audience view, that's perfect. Let me move this over here. So once again, good morning, afternoon, and good evening, everyone. My name is Matthias Gölke. I think you've heard the introduction about my bio already. And within the next roughly 30 minutes, I'm going to give you an overview on our Altairs academic program and our mission behind. So let me jump in here. At the beginning of my presentation, I really want to share with you my favorite quote by Henry Ford, because this is really about our vision. It's coming together is a beginning. Keeping together is progress, and working together is success. This is really something which keeps in our head, which keeps on banging in our head. And throughout the past years, our user base in academia has really grown significantly across the globe. Also because we have significantly invested in our solver technology. And Jim has shown a glimpse, so to speak, on what is available in our portfolio. And here you see some really randomly selected universities from different countries with whom we enjoy a close collaboration. So maybe you see or you recognize certain logos from your areas over here. And the list of universities we're participating or we're collaborating with is, of course, much longer. As Jim indicated in his introduction, the world is changing. And we talk about, or some people call it, mega trends, about electrification, for instance, 3D printing, IoT, automation, and machine learning. Especially machine learning is very popular in these days. And all these changes are actually happening while I speak. And obviously we ourselves, and of course also the new generation of students, somehow have to keep up with all these new technologies. And I really have to admit, this is a big, big challenge also for myself, or at least for myself. We're so busy with our daily tasks, with the load schedule, and to free up time to learn more about the news is really a challenge. And with this slide here, which is really, really colorful, I want to simply show you kind of what is standard in the product design development in CAE. So if you look, for instance, at this sort of cloud over here, it's about EM, it's about antenna design, antenna placement. However, you also have new materials like composite structures included, or lightweight structures, which you can see over here, this kind of bone structures. Safety is, of course, very important, vehicle dynamics, and so on. But next to all these different disciplines which are coming together into one single product, I think we shouldn't forget what is really, really important. It's the soft skills. Students really have to learn to communicate, to talk maybe even different languages, to understand the meaning, the intention of the fellow students, so to speak, to be successful. And this is, by the way, one of the reasons why we support student competitions. And I will talk about student competitions briefly in my presentations as well, So while meeting professors and in fact friends, I'm asked quite often, hey, Matthias, how to best prepare students for the future? And of course, we don't, or I don't have the ultimate answer to this question. Definitely not. So please don't get me wrong on this. However, this question still is influencing what we are doing. We feel and we see that the way tutorials, the way the teaching material looked like in the past years, 10 years back, is not adequate for the demands of today. So how does our engagement with universities look like? And of course, there are at least two levels. It's professors and the students. And professors, in a very simplified way, the situation is you're involved in teaching, you have dedicated teaching needs, you need to update, to change the curriculum, there are examinations coming up, and other things like raising funding, running the research programs, and so on. So how do we help you? By providing, for instance, curriculum material, e-books, e-learning material for teaching, for your classes, technical presentations by what we call domain experts. So they are really the experts of, for instance, crash simulation or antenna design, and also curriculum partnerships and other activities. The other levels is students. Situation should be students are supposed to be really eager to learn. They should be curious about the new technology. And what I'm always asked for while meeting students is about employment. Students want to get a job. They want to get the best job. They want to be hired by the most prestigious company. So the question again is, how do we help students? For instance, we provide students a free student edition, e-learning and a certification program, support, very important, student competitions, internship programs, and ambassador program. And I will explain some of these bullet points in my presentation. But before that, let's have a look at some very general, I say general challenges. How and when to include new technologies in the curriculum. Again, it's also about freeing up time, how to prepare students for the needs of industry. And as I mentioned before, how to help them to get the best jobs. It means somehow you need to free up time to get up to speed with the new technology, at least to understand how this technology can be used. And along with that, updating curriculum material, exercises, and eventually even examinations. On a more individual level, we see, of course, differences between the duration of classes. There are always different time constraints. The teaching objectives are very different. However, there's always one common theme, connecting theory to practical aspects. It's not always a balance. It doesn't need to be a balance, but there's always the trend to show how the theory can be applied to practical aspects. And then, of course, another demand, so to speak, is progressing from the simple exercises, from the simple engineering task, so to speak, to the more advanced level. Jim Ryan was showing a similar graph or a similar image before, the kind of a step approach. So this eventually means you all have different, or we all have different needs. And because of that, we need different solutions. And the great thing is, and I don't want to exaggerate on that point, we provide different solutions, different answers. And let me show you now one simple example. Imagine we are at the introductory level in a class, and we want to teach students the simulation-driven design process with our tool, which is called Inspire. So we start on the left lower area corner with a rather bulky structure. And the students are simply asked how to create out of such a structure a bracket like this. A bracket which is able to sustain certain loads, for instance. And I'm not sure whether you know Inspire, whether you are familiar with our technology. And I like to play a little video. I think the duration is something like 2 minutes. It gives a nice overview on the workflow. The technology is based on the finite element technology and method. And it starts, of course, with material assignments, with loads, with constraints. You may see and observe the graphical user interface is pretty clean, pretty simple. Inspire is the tool which is supposed to be used by designers, by people who are not doing CAE on a daily basis. So many steps are simply automated in the background. So in here, we set up the so-called optimization one. We say, for instance, minimize the mass of the structure and take into account symmetry. What you see now is the so-called concept design. The concept design is the design which is needed to really carry the loads. Everything else is, so to speak, removed out of the structure. You can run an analysis to understand how good your concept design is, but you may observe that the structure, the geometry is rather rough. And we have a technology which is called polynerbs. And by the way, you can do it inside our geometry, inside our tool, or outside in your CAD system. You can import any kind of geometry into Inspire. What we're doing over here, this is the mission behind, we're smoothing the geometry. There are different techniques available. By the way, this video is about 2 years old. Meanwhile, the things are more automated, so the processes are even faster and even easier to handle. So once this smoothing operation is done, and we're really done now, you simply follow the traditional way of applying the finite limit method, meshing, etc., and you can see how your design performs, taking into account the load constraints. This is typically something whenever I show such results or such a process to students where students are really hooked up. I say hooked up, I hope it's the correct description, but students really get absolutely fascinating. And I think this is also very important, that students are fascinated, because then they are open-minded, they're really interested to learn more about it. And my typical recommendation whenever we talk about CAE is let the students first get an understanding on the outcome, and then the willingness to learn more about the theory, about the mathematics behind, is much higher, much different, or very different. So how do we help you? And now I'm getting a little bit in detail. Everything starts over here on our dedicated website, altairuniversity.com. We have different categories like students, for teachers, online courses, support forum, and our learning library. Inside Altair University, your students can download our free student edition, our free ebooks. They have access to our forum, which is very important because we don't leave your students alone. I have a team of 8 engineers who jump into the forum, who answer questions. Of course, they don't answer questions. There's no administrative work on your end. This is all handled between the student and Altair. So you don't need to provide any sort of Excel sheet or official document that this is really a student attending your class. This is now something very special. It's a kind of, say, of favorite topic on my end. It's about how to connect theory aspect. What we call a learning and certification program about 4 years back. The target group, absolute beginners, meaning students who do not know anything about the tools, how to use tools. The vision behind it is quite obvious. It's all about helping you with teaching. But very important, and that's the reason why I wrote it in red letters over here. I tell you, don't teach the tools at the university. This is not needed. We have all the e-learning material, all the documentation available, all the courses are available for students so that they can learn the tool, that they understand how the tool works at home. Students should come to your class and should be ready to listen to your engineering assignment, to your engineering task. I think it's a waste of time if you explain students at the university how the graphical user interface looks like, or what kind of solver formats are supported, etc., etc. This is something you can outsource, put it into a homework assignment. And a lot of professors are really following this kind of trend. And I think it really saves up a lot of time on your end to really help students to better understand the outcome of the simulation. We have currently something like 28 different courses available, and very important for you because we know that not all courses really fit into your curriculum, into your classes. Please let us know. We are more than happy to create dedicated courses for you and for your students. This is, of course, a service available for free. As I mentioned before, the world is changing. And what we see is the need to integrate the different physics or different disciplines into the classes, into even a single tutorial. And that's the reason why we started working, developing on what we call demonstrators. What you see over here is a very simple form of a cantilever project, which allows you in your lab, in your classroom, to discuss, for instance, the analytical solution of a cantilever problem, but also to use the same structure as an introduction into the finite element analysis, like meshing, like mesh size, type of elements to be used, etc., etc. Since we have applied different sensors on the cantilever, somehow the data need to be extracted or need to be read. And that's the reason why we have an Arduino board in here. And as Jim mentioned before, we have the tools available to program the Arduino so that the measurement, the test data over here can be visualized on the monitor. Meaning at the same instance, students can run a test. They can extract the data like acceleration, like the strains, and you have the kind of platform to discuss, for instance, sources of uncertainties. Why are the results, the test results, different than the simulation results? Another example, which is very popular in these days, as you know, it's a robot arm. So here again, the mission behind is combining different physics into one big exercise. What we provide here is solutions to, for instance, topology optimization, load extraction, to understand what kind of forces are acting in these joints, for instance, what kind of stresses are really present in those brackets or in the segments. It's about, as I said, topology optimization. It's about controlling the speed of the motor, the speed of the motion, etc., etc. And we provide a template solution, which may serve as a sort of guideline. I call it guideline for students who are then asked, maybe as part of the homework assignment, to change, for instance, the geometry of the robot arm. And changing the geometry immediately means the forces will be different, etc., etc. And I think, or we think, that adding a physical device into your lecture, into a tutorial, into a project, which students can touch on or can work with directly, is really changing the learning experience dramatically. Then I mentioned that we support you with curriculum material. Over the course of the years, we developed different teaching packages about finite element analysis, structural optimization, nonlinear finite element analysis, and so on. There are a few more teaching packages, work in progress, like e-motor design, for instance. The content of these packages consists of PPTs, reading material, exercises, solved exercises for your end, and capstone projects. Capstone projects are a little bit more demanding because we don't tell the students, click here, click there. We expect the students, again, to understand the tool that was part of the previous homework assignment. And now they simply need to apply the technology or their knowledge to a given task. That's the definition of a capstone project. And now the point is, since the world is changing and everything is really moving so fast, I need to circle back really to the quote which I've shown earlier: working together is success. To make this really successful, we rely on curriculum partners, meaning we rely, in fact, also on your input, because working together, that's again part of the quote by Henry Ford, helps us to create more teaching documents, different teaching documents with a different depth, so to speak, because you are the domain experts. And this is an initiative which was launched a few years back, which we feel is really helpful, especially for you, because you can exchange those teaching packages later on. One example, and I'm personally pretty proud about this example because I know this professor in person, is an exoskeleton project. The different facets of this research is currently integrated in a teaching package. The first results have been shown at our ATC. That's Altair Technology Conference 2018, so last year in Paris. The great thing was, after presentations, 2 companies asked for a follow-up. And this year, there's another ATC taking place in October in Detroit. Kind of updated version of this project will be shown. And there's another exciting, call it presentation, called Human Plus Machine, how Sacros, that's the company name, is revolutionizing the future of work with industrial robotics. The reason why I mention this is for me, it's fantastic to see how close the teaching content is related or is linked to the needs or to the work of companies out there. And I think, again, this is where we need to head to, that the tutorials, the exercises are somehow easy to manage, that you don't need to start from scratch, but they are still, let's say, pretty close to reality. Working together is success. You see, I'm repeating this quote over and over again. Many years back, we established a program which we call Ambassador Program. This is all about reducing the burden on course instructors. So the ambassadors are students we're working closely together with. They assist with creating new teaching content. They develop, for instance, also new tutorials, or they even support students on site at your university. Ambassadors are also help you, if wanted, running tool seminars. So for instance, if you feel, well, everything in the learning and certification program is maybe not the best way, I'd like to have some sort of, let's say, introductory training happening on top. Yes, if you want to, we have ambassadors more or less all over the place who can run trainings for students. And those kind of trainings are typically extremely well received because it's a training from a student to student. And the communication typically between both groups are very easy and very open-minded. Another thing which I mentioned at the very, very beginning, very important, is student competitions. We, Altair, are engaged in supporting and sponsoring different competitions in different levels. I need to admit, like the Vertical Flight Society or Shell Eco Marathon. And by the way, we are a global partner of the Shell Eco Marathon competition, Formula Student in Baja, and so on. Altair is also running, and this is shown on the lower end of this list, Altair-owned competitions like an Altair optimization contest in India or Korea, a very prestigious contest Enlighten, which is all about lightweight design, and contests about electromagnetic field simulation. We provide students participating in student competitions, free licenses, training, of course, support, and more. What I also like to mention over here, and if you're from India, you may have heard about this program already. The title is Altair University Industry Outreach. This is all about bringing together people from academia, professors and students, and industry, with the common goal of developing the CAE skills of students. Now, you may wonder, hey, what is the interest of a company to develop the CAE skills of students? The answer is rather obvious. It's all about hiring. It's all about recruiting. And of course, if both sides, so to speak, fit to each other, if there is a sort of link between both, it's all about research as well. This program is available up and running in India, and currently we are working and striving to develop similar programs with some kind, let's say, of local tone in other regions as well. I'm coming to the end of my overview, and I like to summarize over here our mission once again. We try to provide you exciting content for your classes, really to excite students, to make teaching easier. We provide students with the best resources, with software to help them to become the best engineers and designers that they can be. And again, it's not just about the software, it's all about the support from our side, which I think is really, really important. And eventually become a member of the Altair University ecosystem, because again, working together is success. And I'm really a strong believer of this part over here. Working together is success. Time is so limited, and only if we really free up our mind saying, okay, I'm willing to share something, I'm willing to contribute, only then we can really succeed. And we, Jim, Altair, and myself, we welcome you to contact us. And please really feel free, send me an email to, it's shown over here, Gölke at altair.com, Altair University. That's the EDU, our university internal alias. I'm also a member of this one. Have a look at Altair University for more detailed information, but I actually prefer to set up individual meetings with you to explain you exactly how we can help you. So thank you very much for your attention.
Well, thank you so much, Matthias. That was a really powerful presentation. You should be a university professor. You did such an excellent job.
Oh, thank you.
explaining the key elements of the whole program, particularly I think the sharing part of it. I keep emphasizing that is exactly what part of IFES and IUC, we emphasize that we cannot do everything by ourselves. We have to share with each other and grow together and focus on making students who are more relevant to the challenges that they're facing in the world. So I love it. So great. Thank you so much, Matthias, for enlightening us on this program. And I'm going to get the audience to jump in as they feel appropriate, just with questions and so on, so we can have some discussion here. But before I go to the audience questions, I have a couple of things that I wanted to just get rolling. I noticed in Jim's presentation that you have a strong presence in Michigan Tech University. That's close to my heart because that's where I got my PhD many years back. And I would be curious, from Jim or Matthias, how did because you emphasize, Matthias, the solutions have to be different for different situations. And so here's one situation, Michigan Tech, and I know the context of that institution. So just curious to see what kind of challenges and how you approach them to make this thing work at Michigan Tech, and then maybe then see if since the majority of our audience here today is from Indian engineering colleges, perhaps Matthias, you can elaborate a little bit more about these competitions and the interactions that you have with India, and I know you have a team in India. What have you learned so far in terms of the situation in India, which is obviously quite different from what you have in Michigan Tech or other places around the world, and how has that helped you maybe adapt or your approach to faculty and students in India? So I'm going to leave those two on the table there and let you decide which of you wants to go first and address one or both of those discussion items while I start scanning the other comments that are coming in. Okay.
Okay. Yeah. Thank you. I think Jim, can you answer the first part about Michigan Tech, please?
Certainly. And thanks for the question, Krishna. I think it is a relevant one for any school that is thinking about connecting different courses together in their curriculum. It's relatively easy to teach courses separately. I shouldn't say it's easy, it's straightforward. It gets much more challenging when we want to have the prerequisites for a second course be covered in a first course, because then the faculty have to discuss the handoff and what needs to be covered. In this particular example, as you know, Krishna, from your experience at Michigan Tech, they are very keenly interested in hands-on senior capstone design projects. So everyone, and they get a lot of those projects from industry-nominated projects. So in order to make sure that the students who are working on senior capstone design is sort of the culmination of their undergraduate work, in order to make sure that they're ready to use and apply these tools, they backed up a few courses. So third year, fourth year, earlier, before the capstone, they said, we really need to teach these young people how to do finite element analysis. That's one course. We need to help them know how to do computational fluid dynamics. That's a second course. We need to help them do multi-body dynamics for systems in motion. That's a third course. And then a fourth, I believe, is a combination or a culmination of those leading up to the capstone, which is really the ultimate goal. I hope that helps give more clarity. There's no end of different ways that schools can approach this. That's why I think Matthias is welcoming you to contact him to talk about how you'd like to do it.
Okay, great. Thank you, Jim. Matthias, you want to jump onto the other part in India, because a few questions related to that already, but go ahead.
Okay, so I try to answer this very, very briefly, but in fact, it's a much longer answer. Just some observations and one recommendation. Observation I've made along with my team in India, that there's a kind of really distinct difference between female students and male students. So in my team, in our team, the male students or the male members, the main members, are typically educated towards structural engineering, whereas the female members are really educated towards electronics, which was a quite kind of surprise to me. I don't know whether this was really intentionally, but I was told, yes, in India, women prefer, so to speak, the electrical part. You can say, yes, this is right, or no, I'm not quite sure about it. What I typically really recommend, every once in a while I have an opportunity to travel to India and meeting professors, and when we talk about the academic program, what I really try to highlight and to strengthen is don't put the focus on educate students on the meshing part. Meshing is part of the whole thing. Yes, I agree. But meshing becomes more and more automated. So if the students just know about meshing, they're not really well prepared for what's coming next. So my overall, again, recommendation is involve students in little student projects, like designing even small brackets, like I've shown before. Let students really explore the entire process from the beginning till the very end. As a sort of award at the very end, let the best student or the best student team print their final product. This adds a lot of excitement. And by doing so, students really understand that CAE is not just meshing. They're not limited to meshing. It's everything. It's about exploring different, let's say, product designs. And by doing so, the inspiration of the student is really going up. It's really opening up their mind. And again, because we're short in time, this is, I would say, my recommendation.
Thank you, Matthias. I'm going to hand this over to Anil Kumar Pandit, who's actually a former employee of GE, retired from GE, and is based in Bangalore. He has some comments. Anil, you want to jump in?
Yeah, sure. Can you hear me?
Yeah.
Yes, clearly.
Wonderful, Matthias. Incidentally, just a small comment before I put my question. The ladies would prefer to push a button instead of yanking a big lever. That's why more of electronics.
Okay.
Okay, but now coming to my question, I've been sort of implored by many medium-scale companies who would want to do simulation. Giving a simple example of electromagnetics contactor, how do I know that a certain geometry is going to work better than the other? They have multiple options. They keep on trying, and it's millions of life. It takes time. So simulation is a good answer. But being medium-scale industries, they are not equipped with a lot of simulation tools, but they would be willing to support internship from colleges. So my question is, do we have some colleges who have Altair and who would want to give internship? Maybe they can sit even right in the college and do simulations and then interact with such small industries. That is my question.
Yes. So in India, we have something like between 70 and 90 interns per year working in our different offices, which is, I would say, really a big number. This is one part. So there's always a chance to get one of the students into Altair directly. Even in my team, I have 4, 5 different interns involved. About those kind, let's say, of collaborations, yes, they exist. What is needed is I would need you to bring in touch with my colleague who is in charge of the local region to discuss the details. but we have a strong team, a strong university team, Altair University team, who cares about the university needs in India.
And that is in Bangalore?
Yes, we have a pretty big office in Bangalore. Actually, we have 2 offices by now in Bangalore. We have an office in Hyderabad, in Chennai, in Pune, and in Delhi.
So Anil is in Bangalore, so you can just walk over to the office.
Yeah, I happen to be in Bangalore, but this company which approached me was in Delhi. Since you have an office in Delhi also, maybe on the website I can find all the addresses and the contact person, or could you mail it to me?
Well, if you don't mind, please just send an email with some info to Gölke@altair.com, and I will bring you in touch with my colleagues.
Absolutely fine. Thanks, Matthias.
Thank you very much.
Thank you, Matthias, for those response, and thank you, Anil, for your insightful question. I'm going to go to Aditya Patil. I think he would like to speak or ask a question. Let's see if it works out. Aditya, come in, Aditya. Can you unmute yourself? I'm going to try to unmute you also. Yeah, go ahead, Aditya.
Yes, sir.
You're a student. Are you a student? One of our students, Aditya?
Yes, sir.
Right, go ahead. He's one of our students in one of our colleges in India. So go ahead, Aditya.
Well, sir, very good evening, Matthias, sir. Well, as you said about focusing on machine learning is really very important thing in India, and basically as after electronics and telecommunication, I'm interested in IoT, Internet of Things. Basically, I wanted to ask that shall I share my ideas regarding the paper which I have researched on about Internet of Things and its interoperability for wide access networks?
So Aditya, you're saying you want to share some of your ideas with these folks on Altair and see if there is a fit somewhere with what they're doing and what the ideas that you're coming up with?
Yes, sir.
Okay, so Aditya is a student in one of our colleges, and obviously he's interested in IoT and machine learning, and one of our, obviously thinking ahead and coming up with some ideas, and maybe you're the kind of student who should be part of their competitions and get involved with Altair. That'll be really exciting.
Yeah, definitely. So please really share your thoughts, your suggestions with me. I'm more than happy really to discuss your thoughts with the team in India. Well, because machine learning right now is really a very, very hot topic.
Yes, sir. Really, thank you, sir, for the opportunity. Well, I have researched a paper on the Internet of Things, which is interoperability of IoT in the fields of telecommunications. And basically, the research is done for wide access networks, where the networks are being connected for wide access with the help of satellite communications. So data transmission kind of things which is there should be transmitted at wide areas so that it can be operated by satellite communication. Instead, again, it can go with local area networks. So that will be the advantages for us for data transmission for wide access. And it's yet implemented in India. Maybe the research are going on. So it was a research paper which I have done. So it was the idea from my side.
Cool. Yeah, please share it. I'm more than happy really to come back to you.
Good to hear some of our students active and interacting. This is excellent. Thank you, Aditya.
Should I mail him about this idea?
Please.
Sure.
Please do so.
Keep in touch with the email. I mean, if you look on the screen, you have email IDs, right? So just use that information and please keep in touch and communicate and make things happen. Fantastic. So I have another comment from Mark Fry, and he is saying that he does not have a mic, but I don't know. Can you say something, Mark? You seem to have a mic, but maybe you don't. So I'm going to read out his comment and question, and his comment has to do. It says, "Excellent presentation. Can you give us some idea how many universities worldwide, and particularly in India, maybe are beginning to use Altair products in teaching, and maybe in general, general idea of students,
okay, well, believe it or not, it's really a big number. I know that Altair as a company is still not that well known, but we have a pretty strong presence in industry, even in India. Actually, all the big companies in India are using our technology, and there's a strong link always between the companies and the universities close by, especially the more, let's say, call it prestige universities. Here in Germany, we have, and you know, Germany is pretty small compared to India. We have roughly something like 70 professors, so 70 professors using our technology for teaching. In France, I would say maybe in the order of 40 professors. Maybe globally, I would say in the order of maybe 400 professors, something like that.
Oh, that's impressive. Really, it's really great. So yeah, thank you so much, Matthias. We would like to help you increase that number in India. So so that's the so Mark Fry says thank you. And so as we move forward, obviously this is the first exposure for this community to Altair. How should we think about perhaps next steps in our collaboration with Altair and IFES, and as you know, IFES is a global organization, and IUC, as I mentioned to you earlier, has 150 colleges all over India who are who probably potentially are maybe interested in what you're trying to do. So maybe while we I think I don't see any other questions. So maybe in conclusion, can you maybe walk us through what's going on in your mind in terms of how we can move forward in the next couple of minutes, each of you, Jim and Matthias?
Yeah, Jim, you wanna jump in at that point?
Well, Matthias and I discussed this before this presentation, and we would be delighted if people were interested and motivated to talk with us, and that's why he's got his contact information up here. If you are from different parts of the world, he will help you connect with the appropriate colleagues within Altair. But we expect that each conversation might be different, tailored, personalized to the needs of that school and that faculty group. So please don't be shy about reaching out to us. That gives us a chance to help you achieve your goals that are specific to you and your school.
Yep.
It's really the best way I can. You can read more about us on the web, of course. You can, do Google searches about what we're doing with student competitions and how we're trying to help academia. But I think really the best thing to do is to have a live conversation, and we're prepared to do that with each and every professor that might be interested.
Yeah, in fact, Jim has sent me a link to the work that they're doing at Michigan Tech, and I'll be happy to share that with you if you're interested. So yeah, Matthias, you give you the last word. Just have a couple of minutes left anyway, so
thank you. Thank you very much. So first of all, thank you very much for giving Altair, for giving us the opportunity to present our academic program over here, for arranging everything, for all the support in the past. It's really a pleasure working together with you, Krishna. And I do hope that this is just the beginning of a long-term engagement. And to the audience, again, thank you very much for your interest. And as Jim just said, please really feel free, drop me an email. I'm more than happy really to connect you to our local EDU university account manager, and he or she has enough time to really talk with you about your individual needs. If we see there is a greater interest in a particular product, for instance, we are more than happy to offer a series of training webinars on the web, for instance, or have on-site trainings or whatever. But these steps can then be discussed based on your feedback, based on your needs. So thank you very much again.
Okay, on that note, I would like to thank the audience. We've had about 70 of them, those doing the webinar, so I appreciate that. They're from all over the world, although obviously the majority of them are from India. But I thank everybody who has joined from different parts of the world in this conversation to continue to join our bi-weekly conversations. As you know, every 2 weeks we have an IFES webinar where we connect people people from industry, academia, and society to work together with us. So thank you again, Jim and Matthias from from Altair, and thank you, audience, and goodbye, good night, good morning. Get back to whatever you're doing this day. Thank you.
Thank you. Bye.
Bye.
Bye.